Hello everyone, my name is Maxime Coquerel. I am Director of Cloud Security Architecture for a financial company based in Canada. I'm also a Microsoft MVP on the Azure and security technology. Today, in this presentation, I will try to show you some insight to pen test your AKS cluster. Do not hesitate to reach me. If you have any question, I will try to do my best to answer it. Quick disclaimer before to start, any view or opinion expressed in this presentation are only my opinion, my view, and not necessarily the opinion or view of my current or previous employer. A big thank you to Festive Tech Calendar to organize this event every year. Quick introduction about AKS. AKS is Azure Kubernetes Services. That is a managed offer provided by Microsoft to host and deploy Kubernetes cluster on Azure. The very good thing with these services is the management plane of the Kubernetes cluster is managed by Microsoft and not under your responsibility. In your case, you will be responsible only to manage the control plane. On the control plane, you have the AKS node where the pod runs. It's also possible to integrate different services to your AKS cluster, like Azure Key Vault, if you want to have a services to manage the different secrets of your application or certificate. It's also possible to integrate AKS with Azure SQL if you need to have a SQL database. You have a lot of integration available for your AKS cluster. Before to start and to go deep, I think it's very important for you to understand the different phase of a cloud security pen testing, because that is a little different to on-prem pen testing. The first phase is the planning phase. In this phase, you will meet your customer, you will define the timeline, you will define the scope of the pen test also, because that is very important to be sure as a pen tester or as customer to have the same understanding about which component could be potentially compromised or not. After that, the second phase is the discovery and recon phase. The engagement start, and we will go directly deep with this phase, because what we want to do is we want to understand which components are directly exposed to internet or not. We want to understand if the AKS cluster is maybe public or private, for example. After that, we have a phase of analysis, exploitation. The exploitation phase, we will try to compromise the cluster. And after that, we have a phase of lateral movement. In this phase, we will try to the attacker will try to jump to some other component of your architecture. For example, if the AKS node is compromised, maybe from the AKS node we can try to access to another key vault where your Kubernetes secret are hosted, for example, and an attacker could try also to play with the different permission which can assume from the AKS cluster. And after that, the last phase is the reporting phase. In this phase, it's also very important to enumerate all the findings and to be sure the customer have the right understanding about which findings, the severity of the finding, and also it's also important to provide some advice about how they can fix this finding if it's possible, because it's not possible to fix all the finding. Some finding exist and you need to assume the risk. It's also important to understand that. The next part is a pen testing approach, because as pen tester, you have three different approach, the black box, the gray box, and the white box. With the black box, you know nothing about the AKS cluster. You have maybe only an application endpoint, and from this application endpoint, you will try to discover a ton of information about which services is used or not. And you don't have an access, you don't have an internal access, you are only an external, and you are like an external attacker. After that, you have the gray box. Maybe sometime with the gray box, you have some architecture documents, some documentation, but you still don't have an internal access, and you have the white box access. So white box access, you have generally you have a reader account on the Azure subscription, and with this reader account, you will also have access to all the documentation, all the information related to the architecture. It's also very important to understand the different threat actor as pen tester because you will play different role. That could be an external attacker, generally in a black box testing, but that could be also an internal attacker, or maybe that could be also a compromised DevOps account or SRE account from your team. It's also very, very important to have this understanding because with a different view, the attacker will conduct different attacks. But to help you to map the different potential attacks again on AKS cluster, Microsoft has released a Microsoft Kubernetes threat matrix to help you with that. They try to enumerate all the different attack possible again in AKS cluster. Some attacks are very simple, like for example, to discover and expose dashboard. For example, if you have Kubernetes dashboard directly exposed to internet without any authentication. That could be a big threat. But that could be also more advanced with a malicious admission controller, for example. Now, in few minutes in this presentation, I will try to go deeper and to be more technical to show you some potential threat against your AKS cluster. The first step an attacker will try to do is to determine if your EKS cluster is public or not. And for that is very easy. Just with an NSLOOKUP query, NSLOOKUP, the API server endpoint, you will know if the API server is private or not, because Microsoft use a public DNS server to register private IP to register private AKS cluster. You have an example on the screen. As you can see, the first query, the resolver will answer you the private IP versus with a public API server, the resolver will answer you the public IP. That will give some information to an attacker to identify if we have a public or private EKS cluster. When you have a public API server, sometimes it's also possible to apply some whitelisting to the public API server, but it's also sometimes possible to spoof the source IP to try to spoof to bypass the IP whitelisting in place. If you have a reader access, for example, if you are an internal threat actor, I will recommend you to use Azure Resource Graph. Azure Resource Graph is very powerful services because with a simple query like I have on my screen, it's possible for you to identify the version of the Kubernetes orchestrator, to identify the node pool configure, to identify the node image of the EKS cluster, and also it's also possible to identify for some advanced configuration, if I can say that, to identify if we have Azure policy for EKS enabled or not. And all this information will give you an idea about the security maturity level of the EKS cluster, or maybe not specifically for the EKS cluster, maybe at the organization level, if they are familiar with security or not. A very good thing with that is by default, because it's designed by Microsoft, only the put, post, and delete action are recorded. That means someone with a reader access, if the malicious insider try to only play GET request, that will never be notified by your SOC team in place. And you can try just to list and to try to enumerate the different configuration of your EKS cluster, how many cluster you have, as I said before, which version of the node orchestrator, which version of the node OS image use, if the version is up to date or not. All this information are available without any logging, and that is by default. Now, if we go more deep about airbag misconfiguration, what I will try to show you and to present you in this case, it's possible because by design, Microsoft has released an API, and with this API, it's possible to fetch the cluster admin credential. And if you have the right permission, it's possible to fetch the credential of the cluster admin, and after that you can usurp this identity against the AKS cluster. If you want to play this attack, you can use the microburst security framework developed by the NetSpy team. With this security framework, you have a ton of security capability to get asset password from AKS, from Azure Container Registry, from app services, and that is very nice because just with a simple query like get asset password AKS yes, you will fetch automatically the cluster admin credential. Now you have an example of the AKS cluster admin credential you can have, and you can use this credential and try to access with this credential to try to do an authentication again the API server. And if the API server is public without any authentication, that is easy. It's very easy. If the API server is private, you need to be connected on the same subnetwork, or you need to have a VNet peering, a malicious VNet peering against the subnet where the EKS cluster is deployed. Another very interesting command provided by Microsoft is AKS command invoke, because natively from the Azure CLI, if you have a private cluster, you can run this command and you can use this command to fetch information like kubectl get pod and to list the pod of the kube system namespace, and you can just play this command with from your Azure CLI and that all is very easy. And if you have a AKS private cluster, that will also bypass the network configuration in place. Now, if we go deeper, we can talk about node level attack, because that is very interesting because a lot of old AKS cluster were deployed with a service principal identity, and this service principal identity are stored in clear text in the azure.json config file. And by default, the service principal assigned to the cluster will get the ECR pool role assigned to the service principal, but a lot of misconfiguration are also present with the service principal because sometimes when people doesn't have a right understanding about EKS, they try to assign a permission to the service principal to access to key vault, for example, or to Azure SQL because they don't understand correctly about how the identity model for EKS works. And from this service principal, if you have access to the azure.json file, you will have the service principal ID and service principal password stored in clear text, and you can use that to access to the Azure subscription, and also to try to usurp the identity. This identity. Now, Microsoft tried to recommend to use the system assign manage identity to replace this service principal, because to have a service principal in Azure, for my opinion, is a big mistake because if a lot of organizations don't have a right rotation process in place to rotate the service principal, and if someone steals the service principal, if you don't have an Azure Active Directory P2 with conditional access configured for service principal, someone can use this service principal from a public hotspot and try to access to your Azure subscription. To access to the node, to do some node level attack, a lot of clusters are maybe not configure correctly. And if you have a privileged container, you can try to mount the Node OS file system and try to access to this Azure.json file. It's also possible for a malicious insider from the DevOps team or SRE team to just do an SSH access to the node. Now it's just for your information. Now, since few weeks, it's possible to disable SSH access at the AKS node level. I will recommend you to do that if you want to have an AKS cluster hardened. If you want to enforce security control inside your AKS cluster, I will recommend you to use Azure Policy for AKS, or if you don't want to use that, some additional solution exists like Kyverno policy or OPA gatekeeper policy. You can do that, but the recommended solution provided by Microsoft is to use Azure Policy for AKS. Just to give you more detail about that, that is directly extract from the Microsoft documentation page. I invent nothing in this case. All this information are public. It's also possible to play network attack against AKS cluster, because by default, when you deploy a Kubernetes cluster, the network configuration is like a layer 2 network, and IRP spoofing attack are also present in this case, and DNS spoofing. It's also possible to capture the traffic between the different pods if you have the right access. All these attacks are possible if you can compromise in first the identity model of the Kubernetes cluster. And identity in this case is maybe one or two biggest misconfiguration we can find in the different audit I can do. Another attack, more an advanced attack in this case, is to use a malicious admission controller. That is very nice because a lot of people try to reuse existing admission controller from internet. So they pull that from GitHub and they try to deploy that. They try to deploy that in their AKS cluster, but with a malicious controller. In this example, I will show you how it's possible to have a malicious admission controller just to swipe the container image. In this case, someone tried to just run a kubectl run nginx image nginx, but behind the scene, the AKS cluster will not pull the nginx image, but a compromise image, a malicious image, because the admission controller will be in front of that and will do the malicious job. And if you want to play with all these different technique attack, I tried to show you. You can use a multi-tool Kubernetes pentest image. I will recommend you to deploy that in your test and lab environment and try to understand how that works. And what I would like to try to share with you is Kubernetes and AKS are very complex. To have a right identity model, to have the right permission in place, it's very, very complex. And that can also open a lot of door for malicious actor. And in my advice, I will recommend you to go step by step. And it's very easy to want to build a complex architecture with a lot of integration with Azure SQL DB, with Azure Key Vault, with a ton of different services, but start small and grow. When you have the right understanding, when you think you have a good maturity level, when you think your developer also can onboard the application in the cluster, because to have a very complex cluster, it's right, but that will cost you a lot of money and time to manage that and to have a secure model in place for that. This presentation was only an introduction. If you are interested to watch more advanced presentation, I will try to record some advanced presentation in the upcoming months. And for that, do not hesitate to follow me on Twitter or on LinkedIn if you have any question. And thanks again for your time today. And I wish you a great end of year and take time with your friend and your family. That is the very important thing to do, I think. See you again. See you next year. Bye.